live from Earth. It's Space Radio. This is Paul Sutter, and coming up, we're talking about zombie space pictures and attempt no landings on Europa because there's giant spikes of doom. And of course, taking listener questions about all things in the universe, because that's what this show is about. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about TikTok. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI, and for the next half hour, your agent to the stars. Got an exciting show for you today on Space Radio, where we talk about all the amazing things in the universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus. So call 888-581-0708 anytime. You can leave a voicemail or talk to me live. Get those calls in. You can also follow along with the live streams, joining the space cadets from around the world. I see Salt Lake City. I see Amsterdam. I see Pennsylvania. I see Texas. That is right. All over the world joining this live show. Go to spaceradioshow.com for the links of how you can follow along. And from Denmark, getting in at the last second from Denmark. We'll take questions that you send there too. Seriously, folks, I prepped 10 minutes to show material tops, and actually less than that. So get those calls in. How you doing, space cadets? Good to see you alive again. I know it's been a couple weeks. I missed you. Missed all of you. Send me those questions. Nancy, thank you so much for wrangling them, organizing those questions for me. And Mr. Moebius, we have a caller. Sorry, you can't read your paper now. John Michael Gautier, I don't know. So you've got that link, because I've got an interview with John Michael Gautier that's going to go live on YouTube soon after this show. I don't know if you can post the link or if Nancy and I can allow the link. Actually, I think I have a link here. So I'm just going to copy it, and I'm going to put it in the chat for all you. There it is. Go there. There'll be a really, really fun interview I did with John Michael Gautier. It'll go live right after the show. Don't go now. Don't go now. Stay on this show, people, and then do that thing. Before I start taking calls, I wanted to share some interesting bits of news I caught recently. And there's a story. It's a little bit of an obscure astronomy story. It didn't make a big splash. It didn't have, a fancy, sexy title, but it really captured me as something I really wanted to share with all of you. And it's this wonderful project called Astronomy Rewind. And it's led by Alyssa Goodman over at the Harvard-Smithsonian Center for Astrophysics. And the problem that she's trying to solve is that there are decades of amazing astronomy, of images, of spectra, of data, of real observations that back in the day, before digitization, before computers, were printed in journals, in the Astrophysical Journal, for example, or Astronomy and Astrophysics, all these various academic journals that stretch back for over a century. And the images were printed in there, and then they're done. They weren't saved. They weren't backed up in the cloud. They weren't posted to Instagram. They're just in the journal, and they're starting to deteriorate. And modern day astronomers have a really hard time because we are so lazy. We're so used to having all of our journal articles online, instantly shareable, easily searchable, finding the data, having data archives, they're tagged, everything. The very concept of, wait a minute, in order to dig into old astronomy and dig this up, I have to open a book? I have to go to the library? That's going to take forever. And so we're lazy. And so we want to digitize them, but we also need to categorize them. So it's this project called Astronomy Rewind, which is taking this astronomy data that is dead and bringing it back to life hence the name Zombie Astronomy. And it's a citizen science project. You can go to zooniverse.org, and you can sign up to be a part of Astronomy Rewind. And you, yes, you get to classify these images and figure out where they are in the sky, what they're trying to represent, what the important scales are, like doing that very basic data entry categorization so that it can be used for modern astronomy. And we're interested in these images, not just because of like historical preservation or some sense of nostalgia. It's because we're learning more and more about how important changes in the night sky are, how astronomical events happen on human timescales, that stars and galaxies can evolve in a measurable way over the course of years and decades and centuries. And now that we have years and decades and centuries of astronomical scientific observation under our belt, we should put this in to the general conversation, the general accessibility of astronomy, so that we can do this kind of, okay, we see a nebula. How did it look 50 years ago, 70 years ago, 100 years ago? Has it changed? Why has it changed? We can learn about the evolution, even the birth and the contents of that nebula, for example, by looking at comparing modern day observations to observations of the past. And so this is critically important work. Good job, Alyssa Goodman. Good job, Zooniverse. And good job, the human race, for joining in this citizen science effort. That's zooniverse.org. Is anyone on the live stream? Oh, so there's a question like, does anyone sabotage the whole event by like misclassifying like, this one's a rodeo clown? This one. So the way these citizen science projects work is that multiple people will classify the exact same image, and different reviewers will have different scores. They'll have different weights, different reliabilities. And they will take it from there. And so you get a better sense. So one person can't really sabotage the whole thing. Are any of the Space Cadets members of Zooniverse? If you are, let people know and what your score is, if you have a score. And we got a caller. So I know caller, Shay, I see you in the queue. We're going to bring you into the room. What I'm going to do is I'm going to start the next segment. I'm going to introduce you, and then we're going to chat. So you're going to hear a little tone in just a second. That means you're live. You're on the air. And so what you need to do in the background, however you're listening to this, you need to mute that because I talk and then it comes back through.
Gotcha. I'm good to go.
All right, that's on. So I'm going to introduce you. I can still hear you.
Can you?
Do you have me on speakerphone?
No, hang on 1 sec. Sorry. Is this better?
I think that sounds a lot better. No,
Sorry
Greg,
about that.
No, actually, Greg, do you hear that? So what I'll do to get around this, I'm gonna put you on mute. I'll introduce you. I'll unmute you. Then you can ask your question, and then I'm gonna have to put you back on mute so that I can answer it. Does that sound good?
That sounds great. Thank you.
Okay. All right. Here we go. Wait a minute. I didn't close out that last section. That's the latest and greatest when it comes to space, but now it's time to have a conversation. We've got a caller on the line. Hey there, Shay. Thanks for calling Space Radio. Where on earth are you?
I'm over in Arizona.
Over in Arizona. Excellent. What's your question today? What are you curious about?
So my question is a little bit to do with redshift, blue shift, as well as the acceleration of the universe. I'm super curious about this and see if we're even about it. Like, our expectation has always been, that the universe is expanding, and we've confirmed that through redshift of like light coming at us. But we also know that gravity can make light redshift as well. So what if we're wrong about the fact that the universe is expanding and it could be static, and it's just the fact that it's going through so much intergalactic medium that everything is redshifting towards us because of that instead. Is that possible?
Oh, that is such a wonderful question. This is a really, really fundamental question. And I'm so glad you asked, because I love it when people ask questions of how do we know? You shouldn't take, all listeners, all space cadets listening right now, you shouldn't take anything I say for granted. Just because I say it doesn't make it true, doesn't make it accurate. When I say things, it's backed up by evidence. It's backed up by the scientific method. So any opportunity I have to explain that method, I'm going to take it. And the big question here is, I can say something simple and straightforward, like we live in an expanding universe. A long time ago, the galaxies on average were closer together, and now they're not so close. And in the future, they'll be even further apart. That is not an easy statement to make. I mean, I said it really easily, but it takes a lot of evidence to build up to that kind of statement. And in fact, if we go all the way back to the mid-1920s when Edwin Hubble discovered the expansion of the universe, he didn't really discover the expansion of the universe. He discovered redshift. He discovered that on average, the light coming from distant galaxies was redder than it should be. That was his fundamental observation. And we have to make a jump from that statement of the light coming from distant galaxies is redder than it ought to be, to we live in an expanding universe. And in fact, when he made this announcement, when he wrote the paper, it was a very short paper, it was just like 4 pages long. He talked mostly about the data and his methods. And at the end, he said, maybe we live in an expanding universe. There's been some theories. There's this thing called general relativity that you may have heard of. Seems to be pretty exciting. But he left it at that. And then other scientists came in. And one of the biggest ones to come in to attempt to interpret these results was one of my favorite astronomers by the name of Fritz Zwicky. Fritz Zwicky, amazing personality. And he wrote a paper outlining, this is a very, very important paper, outlining, okay, we have this raw data. Light from distant galaxies appears to be redder than it should be. How can we interpret this? What are the possible explanations for it? One explanation is that maybe light from the distant galaxies interacts with dust. Dust can shift things down. Dust can make things redder like a sunset. Maybe light somehow gets tired. Maybe light slows down or loses energy as it travels. Or maybe we live in an expanding universe. And the big thing that absolutely kills all other explanations for the redshift that we observe of light coming from distant galaxies is that there's a relationship between the distance to the galaxy and the amount of redshift. Where if we look at a particular galaxy, we'll see a certain amount of redshift. It'll look a little bit redder. And then if we look at a galaxy twice as far away, it's twice as red. Or the light is shifted down twice as much. And if we look at a galaxy 4 times further away, it's 4 times shifted. 8 times. You get the idea. There's a relationship there. And if light were to interact with dust, say, and get redder in the process of traveling, that it wasn't due to an expanding universe, this relationship would break down, because the way that light interacts with dust, we can test this, we can observe this, we can measure it, doesn't lead to that kind of result. The only result, the only answer we have that satisfies that raw evidence is that every galaxy on average is getting further away from every other galaxy, and hence we live in an expanding universe. Since then, we have multiple independent lines of evidence that give us confidence that we live in an expanding universe, but that was the first. And right off the bat, all other interpretations simply didn't make the cut. Excellent question, Shay. Absolutely love it. Thank you so much for asking. I've got to take a quick break here, folks. This show is brought to you by you. You need to go to patreon.com/PMSutter to learn how you can support the show. It really is you that's keeping this show on the air. That's patreon.com/PMSutter. Especially big thanks to my top Patreon contributors this month, Robert R., Dan M., Matthew K., and Evan T. Thank you so much, and to all the others that are keeping this show alive. See you after the break. Great question, Shay. Absolutely love it. Thank you so much for calling. And I think we'll do the first voicemail, and I'll do some space to get at questions. What we got cooking today? Oh yeah, are there any missions in the near future to Jupiter's moon, and especially Europa? Love it. Love it, love it, love it. Maybe that, and then the supermassive black hole. I've got 3 questions, 9 minutes. 3 minutes per question. All right, so Space Cadets, what you're going to hear, a little bit of static because we hook up the computer and the computer gives us some static, and it's going to play a voicemail, and then, but then the static will go away. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. I've got a question here lined up on the voicemail, time shifted. You can join the conversation too by calling 888-581-0708. You can talk to me live like Shay just did, or you can leave a voicemail, which is still cool, but just slightly less interesting, but still cool. Go to spaceradioshow.com for the links. Greg, play that funky voicemail.
Hello, my name is Steve. I am calling from Portland, Oregon. Have a curious question about the light cone, the definition of the surface in space-time that marks out the possible directions for light rays passing through a given event. Look forward to the show. Thank you.
All right. Excellent question, Steve, about light cones. Ooh, light cones. I love jargon words. All right. I live and breathe jargon words in astronomy and physics. And I know that's kind of a barrier to entry for non-scientists to understand and appreciate the joys of science. But there's some wonderful words here. I mean, how many times? Raise your hand. I know I can't see you, but raise your hand if you have ever encountered a radio show where the phrase light cone came up. I dare you. But here we are talking about light cones, and all of you are about to learn about light cones. This is so cool. This is a concept that comes up in special relativity, Einstein's theory of motion and the relationship between time and space and mass and energy. Wonderful theory. Good job, Einstein. A light cone comes from the fact that our universe has a speed limit. Nothing can go faster than the speed of light. That is the ultimate fastest you can go. This means there is a limitation to what you can do in the future. There is a limitation to places you can go in the future. There is a limitation to how events can influence each other, either from the past and then they influence each other now, or they have the potential to influence each other now, or if objects or events are separated by a certain distance, can they ever interact? Can they ever talk to each other in the future? And the light cone gives us a measure of what we can influence in the future. So I'm here. Right now, I'm in a certain position in space. I'm traveling at a certain speed. And my light cone, this mathematical measure, tells me what I am allowed to influence in my own future, knowing that I cannot travel faster than the speed of light. So if there's a distant object and it's traveling, it's doing its own thing, maybe it's speeding away from me, I know if it's outside of my light cone, then I know I can never go to it. It can never come to me. I can never communicate with it. I can never send a signal to it. I can never get a signal from it ever again in the future. Is outside my light cone. The light cone is the limitation of what you're allowed to do in the future. Thank you so much, Steve, for that wonderful question. Now, I do have a bunch of Space Cadet questions all lined up, and of course, I don't want to neglect the lovely Space Cadets who are watching this show live on YouTube and Twitch. First question, are there any missions in the near future to Jupiter's moons and especially Europa? The big deal, in case you haven't been paying attention, is that the icy moons of the outer worlds have a secret. The icy moons of the outer world are locked in ice. They have crusts of ice, but underneath that ice are liquid water oceans that span the entire globes. I mean, it's not a little bit of water. It's not a drop. It's not like some, maybe there's water, but it's only there in a little spot in the summertime. No, there's more liquid water on Europa than there is on the Earth. Way more. But we can't see it because it's locked underneath 100 miles of rock hard ice. So, but we know it's there. That's another show of how we know it's there. But we want to investigate it because, if there's water, maybe there's a chance there's life. I'm not saying there's life. I'm saying there's a chance for life because life, as we know, requires liquid water. So, how do we check this out? Well, one way would be to say send a mission to Europa, land on Europa, and drill down through 100 miles of rock hard ice, and then build a submarine. I don't know. Things get a little bit vague here. We tool around the ocean for a little bit with our searchlights. Europa and Jacques Cousteau looking at the world of Europa. Apologize to every French-speaking person for that accent. And see if there's any like space whales or something swimming around. That's kind of challenging. There are missions headed to Jupiter, both by NASA and by the European Space Agency. NASA's mission is called the Europa Clipper, and the European Space Agency's mission is called JUICE for the Jupiter Icy Moon Explorer. And they're not going to crash into Europa. They're not going to land in Europa. What the icy moons have that's really, really cool is they have cracks. They have holes. And sometimes the liquid water squirts out from the icy crust and blows out into space. So the water comes to us. We don't have to go to the water. The water comes to us. This means we can send a probe, put it in orbit around something like Europa, and splash it through the plumes that sometimes get ejected into space, take a little taste. Will we detect life in those plumes? Probably not. If there is life, will we see maybe the right chemical signature that's required, the soupy mix that you need to create life? Maybe, maybe not. It's too difficult to see, to tell from distant Earth-based observations. We have to go there and actually take a little taste, bottle up some of that European water and drink it and see if it has, electrolytes or something, what European plants crave. And those are the missions. Those are coming up over the next decade or so. Both the Europeans and NASA are launching missions to the icy outer worlds to hunt for life. There are plans, following up on that, Raj Luthra is asking over on YouTube, are there plans for an actual submersible to go to Europa? There are plans, but right now they're like design sketches. That'll be the next thing. If the orbiters find something interesting, something juicy in the JUICE mission, maybe, then the next thing will definitely be a lander. Good question. Good question. Now, in the last minute or so, Cirilio is asking over on YouTube, why is the supermassive black hole in Andromeda so much bigger than the one in Milky Way? So, supermassive black holes, giant black holes, seems that every single galaxy in the universe has a giant black hole, and they seem to be connected. The size of the galaxy seems to be connected to the size of the black hole. However, that's a general statistical relationship. It's not exactly if you have a galaxy twice as big, you'll have a black hole twice as big. There can be variations. The Andromeda galaxy might be more massive than the Milky Way, it might be less massive, it might have more stars, might have less stars. It's a little bit hard to pin down. And its black hole, the size of its black hole is a little bit hard to pin down too, because, it's all the way over there in another galaxy. and black holes, even supermassive ones, are relatively small. So estimates are a little bit fuzzy here, but it looks like the one in Andromeda might be bigger than the one in the Milky Way, even though Andromeda might be a little bit smaller. I'm just going to say, let's just wait. Let's just wait on that. We need a lot more data before we fully understand that relationship. And we need a lot more theory. We need a lot more work to fully understand the relationship between black holes and their hosts. We're almost out of time today on Space Radio. But before we go, it's time for the Blue Shift. Oh, hey, John Michael Gautier is here. Welcome, John Michael Gautier. I'll plug the show again. In fact, it might still be. I'm going to post a link for you guys after the show, which we're wrapping up here soon. Go check out the interview I did. The wonderful interview that John Michael Gautier did of me. It was a really, really fun interview, and it'll be a really fun video for you. Blue Shift. How you doing, Space Cadets? Hope you're thinking of titles for today's show. Because I'm not good at picking titles and you guys are so good. I'm Paul Sutter and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get just a little bit closer to you. And as promised, I want to talk about TikTok. That's right, TikTok. So you know that I love combining science with the arts to reach new audiences. I get a lot out of it as the scientist and science communicator. I get to reach new audiences. I find new ways to express what I know and what I love about the universe through astronomy and physics and science. Artists love it too. One, because I'm a pretty fun guy, and two, because it's a new source of inspiration. It's a new source of stories for them to tell. And for the past year, I've been working with a modern dance company based out of New York called Siren Modern Dance. I've been working with them a lot. I've been following my social media. You've seen some updates from me about that. And they're coming here. They're coming to Columbus, hosted by the Steam Factory at Ohio State, where they're spending a week here. We're workshopping. We're developing sections of the dance and the performance and the narration. Yes, I'm involved in the performance, not as a dancer because no one would pay to see that, but as a talker of science, that might be better. And the nature of this performance that we're developing it's called TikTok. It's about time. It's about how do we understand time? How do we look at time through the lens of physics, in the lens of science? How do we understand it? How we wrap our minds around it? How we deal with it as people, especially these really advanced concepts that come to us from physics about time, even though we don't understand time at all. Dance is kind of about that too. They're coming for a workshop, but WCBE is hosting an event. A performance. It's not like a premiere because we're not done with the dance. It's like a work in progress, a studio showing. We're going to show you what we have so far, and what we have so far is really, really fun. It will be at the Steam Factory on the evening of Saturday, October 27th. You can go to WCBE.org for tickets. Tickets do go to support WCBE 90.5 FM, the wonderful hosts of this radio show. And you get to see a fun performance. We'll have a Q&A with me and with the choreographers and dancers to see how we create something like this. And there's going to be food too. There's going to be food, definitely desserts provided by a little of Bake Shop, and probably some more food. Go to WCBE.org for tickets. And speaking of tickets, if you haven't got a ticket yet for the Ireland Astro Tour, go to astrotours.co, and get a link or get a ticket for the Ireland trip. There's only a few spots left and the registration deadline is closing soon. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. I'm Paul Sutter. This show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. Show is also brought to you by you. Go to patreon.com/pmsutter to learn how you can contribute. And I don't know why I'm using this inflection in my voice a lot in the show today, but there it is. Thanks to Greg Moebius for producing, Nancy Graziano for wrangling the Space Cadets. Dan Michalka for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708. Join me on the air. You can also catch the Space Cadet live stream on YouTube and Twitch. Go to spaceradioshow.com for the links. And thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. And Space Kids, I don't know. I fidget. So I fidget whenever I talk. I'm always fidgeting with something. And I have a pen here, and I was fidgeting with the pen. I dropped the pen in the middle of my segment. I fidget with a notepad. I don't even know why I have a notepad and a pen. Just in case. Just in case. It gives me something to fidget it with, I guess. Maybe I should get a fidget spinner. Are those things still popular? Are fidget spinners still in? I feel like they're not. I feel like fidget spinners are not a thing anymore, and it's not cool to say, I'm going to go get a fidget spinner. Thank you, Nightbot, for the link to Astro Tours. Thank you, Nancy, for putting that in. Nightbot. What's my title? What's my show title? Oh, perfect, Nancy. SirenDance.org. Beautiful. Those are my partners on the TikTok project. Wonderful, wonderful, amazing choreographers, phenomenal dancers. I love working them. Europa or bust? I like Europa or bust. Ross, you're not supposed to watch the video yet. You're supposed to do it after Space Radio. When is the live show from the cruise being released? So I did a Space Radio. We just did an audio recording of that because the video just wasn't really working out. So it's on spaceradioshow.com. You can hear the audio of that. We don't have a YouTube version of that. But I did do a video with Fraser. He did a question show with me. That's over on Fraser Kane's YouTube channel. And we also did a discussion on the Fermi paradox. And I'm pretty sure that's live. I think that's out now, but I haven't seen a link for it. If I get a link, I'll share that. Oh, hey. Hey, Siren. Thanks for joining the show. Thank you, everyone, for a wonderful show. All the amazing questions. By the way, I know a lot of you ask a bunch of questions, both for this and Ask a Spaceman, and I don't get to answer all the questions. Don't worry. I'm working on it. That's all I'll say. I'm working on another thing. So you can keep asking me questions. So just stay tuned for that. I'll see you